Hi there, how's it going? Welcome back to another episode of Brain Training, a place where I train my English by explaining LeetCode solutions. And today we got here the 868 binary gap from LeetCode. I'm just trying this question because actually I was kind of trying to get some interview training using Codility because from my experience, this is the platform that is most used for this type of interview process. But for some weird reason, I cannot log in. And so I just searched for a equivalent question, similar question on LeetCode. And here we are, a binary gap, just like the Codility one. A little different, actually. Codility one, we have to find this gap, but it's basically the amount of zeros we have between ones. And for LeetCode, actually, it's quite different. So let's read this. Let's dive into. Give a positive integer. So we already know that we're always going to receive positive integers. Find and return the longest distance between any two adjacent ones in the binary representation of n. Binary representation of 22 is this. And we have to find the longest distance between any two adjacent ones. Two ones are adjacent if there are only zeros separating them, possibly no zeros. If we have only zeros separating them or no zero at all, this is consider a adjacent one. So this is adjacent one. This part over here, I don't know if you can see. This part over here is adjacent one, and this part in this entire thing over here are two adjacent ones. The distance between two ones is the absolute difference between their bit position. So each one over here is considered a bit. 8 of those is a byte. A bit, I think it's bit. So we have 0, 1, 2, 3, 4. Just like this. Let's say that this is their position, right? And the distance between them is the difference between their bit positions. So this over here, let's say these two binaries, these two ones can be calculated as 0 minus, in this case, let's calculate this one, minus 3 is equal to 3. We use the example they give us. So that's it. 1 and 1 over here. So 0 minus 3 is equals 3. That's it. So we have some examples here explaining whatever. So we have to find this. We have to find the distance between the longest distance in the binary representation, right? So what we're going to do here to find the longest position, the longest distance between two ones. The technique simple is 2 pointers. That's the technique we're going to use, 2 pointers. So first pointer will be always in the beginning of this binary representation. So we're going to use I as always. And we're going to also use J, but J will be initialized with -1, and in the beginning of the algorithm, J we're not going to point to any position. So we're going to start our iteration. What we do in our iteration, first of all, we just check whether or not we are pointing to a 1. So in this case, in the first iteration, we are not pointing to 1, and then we're just going to move forward. So now we are pointing to 1. What we do now? First thing we have to check if J is different from -1. Why? Because we have to check whether or not we already initialized J. If this is true, that means that we are looking at a next one. So we already have J pointing to a previous one, and now we are good to calculate the distance. But let's say this is not the case. So here we have a to do. If not, what we're going to do. So if J is still not initialized, we have to initialize J. So is this true? It is not. So we're not going to do anything. We're not going to enter in this block over here. And we're just going to initialize J with what? With the I value, with the same position as I. So we're going to point to the same position. This is the initialization. of our loop. So then we are keep going till we reach another one in our loop. So this time, J is different from -1, which means J is pointing to a valid one over here. And with this information, we are good to calculate the distance. So now we're going to calculate this distance over here. It means that we find two adjacent ones. That's it. So when we find two adjacent ones, what we do is we're going to calculate the distance. So distance, let's say we just initialize distance here, distance with 0. So distance is max because we want the longest distance between two adjacent ones. So max of distance, the value we already have, the last distance we calculated, which in this case in the beginning is 0, but you got the idea, and the I minus J. In this case, the distance is 1 here, 2, and 3. So 3 minus 1 is equal 3 minus 1 is equal 2. So this current distance is 2. And then we keep going. So, and then again, we have to update J. So J will be updated with this, will point to the same one as the pointer I. So we can start over. And I will keep moving to find the next one. We're going to calculate this again and update the distance value, reset J to I position, and calculate again until we reach the end of the loop. And we break the loop with the distance, the greatest, the max of the distance we find. That's how we're going to do. That's how our algorithm works. So let's write this down. First thing we have to do here, of course, is to find the binary representation of the integer we receive as input. And Kotlin, we do like this. We can do well using Java, but the Kotlin way is like this. Binary, and what we do is just simple. To string, but base 2. We just pass 2 here. This represents the base 2. After this operation, we have this representation over here. That's what this to string does. So now we have the binary representation. What we're going to do here is declare our variables, our 2 pointers actually. Var j will start with -1. And I variable we're just going to declare inside a for loop. So for I in binary, look, this is Kotlin as well. Binary indices. Strings in Kotlin has this convenient property, which is return I think is a range of values. So a range from 0 to the size -1. So that's what it is. Next step, like I mentioned, first thing we check if binary, the position we are at, like I position, is equal to 1. Why we are checking this? Because each position here is a char. This is why we have to use this symbol here. So we check if this char over here is a 1. If so, first we check whether or not J is different from -1. Because here, just when we have J different from -1, we have 2 adjacent ones. So we do like, oh yeah, I forgot about the other variable. I forgot about the distance. Var distance start with 0. So here we're gonna set distance equals max of distance I minus J. So this is how we calculate the distance, the maximum distance so far. And inside this if, we also have to update J with I value. So that's what we do. That's all we need, and then we just return distance. That's all. That's a really smart approach in my opinion, because look, in the description we should return if there are no 2 adjacent ones, return 0. But this is something we don't need even to check in our code, because if we never initialize J, it means that we didn't find any adjacent one. So distance will remain 0. That's what we are returning here. So let's give this a try. Let's see if I didn't have any typos here. So everything looks fine, and let's submit this. And yes, we pass. It's not a very good performance, so we have a little improvement we can do in this code by using a Java version of this conversion over here, because to string seems like to be a bad algorithm. So we can do like this: integer to binary string and integer. Okay, integer. There's a typo there. Yeah, it compiles. Let's run it to submit this. Yes, yeah, as you can see, it's a little bit better. A little bit better just by using Java version of this conversion. So Kotlin sometimes not that good as Java. So this is the interoperability of Java and Kotlin Java. So we can use Java algorithms, Java functions. This is really good. Okay, that's how we implement it. So as for the time complexity of this algorithm is O of log of n. That's crazy, right? I thought this time complexity was n, O of n, like this, but no, it's log of n. Why? Because of this over here, this method. What this method is doing is just grabbing n, it's just taking n, the number, and dividing by 2 until the result, the final result is 0. Let's say we have 8 divided by 2, the result is 4. The remaining is equals 0. And then we have 4 divided by 2, remaining 0. And then we have 2 divided by 2, remaining 0. And then 1 divided by 2 is 0, because integer division, but the remaining is 1. So we reach 0 over here. So when we reach 0, we cannot divide anything by 0. So as you can see here, from backwards, we have the binary, look, 0, 0, 0, binary representation of 8. And this process is also known as log base 2 of 8. This log is just how many times we can divide a number by the base. In this case, base 2, which is binary. So this code over here is O log base 2 of n. And that's what makes our for loop as well, because our for loop as well is already a O log n. So that's it. That's 2 places. So this is why we have this time complexity, crazy time complexity. I'm not gonna lie, I have to learn why this is the case and just explain it. So space complexity. Also the same thing, because of this binary string we have here, this representation. So it's O log n, because as much as the input grows, this string over here will be increasing size, but log n size. So it's gonna, always dividing by 2 and allocate more space for this string over here. Have more chars, if you will. And that's it. That's all we need to solve this beautiful problem. Really interesting problem. I really love it. Binary gap 868. That's really good. Really nice. Really nice. See you in the next one.